This is chapter 6-3, proving quadrilaterals are parallelograms. Okay, please copy your codes. To begin this, let's recall what a parallelogram is. It is a quadrilateral or four-sided polygon that says that the two opposite sides are parallel to one another. For example, if I have parallelogram ABCD, that means that automatically AB is going to be parallel to CD, or also both have to happen. Also, that means that AD is parallel to BC. So both pairs have to be parallel to one another. AB has to be parallel to CD, and at the same time, AD has to be parallel to BC. All right, let's get started with some theorems. This is Theorem 6.6. Remember, in this particular one that we have a number instead of a whole name. And in this theorem, it says if both pairs of opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. So in this particular case, I see that segment AB is congruent to CD. That's the first pair. I have to do two things. I have to have one pair of congruent sides, and I have to have a second pair. Well, where's the second pair of congruent sides? AD is congruent to the length of BC. Because I have two pairs of congruent sides, that means that the quadrilateral ABCD is a parallelogram. I'll say that again. What Theorem 6.6 is saying, that I have to have two pairs of congruent opposite sides. So here's the first pair. This is the first pair. AB and CD are the first pair that are congruent in length. And then here's the second pair, AD and BC. Remember, in a pair you have two. So the first pair is AB and CD. So AB is congruent to CD. This is our first pair. And then our second pair is AD is congruent to CB. Okay? And then because I have one pair and a second pair that are congruent, that means that the quadrilateral ABCD is a parallelogram. Right? Here's Theorem 6.7. If both pairs of opposite angles in a quadrilateral are congruent, then the quadrilateral is going to be called a parallelogram. Okay, remember, a parallelogram is a quadrilateral, a four-sided polygon. Right? But in the parallelogram, what's special about it, it means that the two opposite sides will be parallel to one another. And then these two are parallel to one another. Okay? But if they don't mark the parallel symbols on these, I know that this quadrilateral ABCD is a parallelogram if they give me this information. They give me the information that the two opposite angles are congruent. So angle D is congruent to angle B, and then angle A is congruent to angle C. And I'll write that. So I need two pairs of opposite angles being congruent to one another. So here's our first pair. Angle A is congruent to angle C, and then here's our second pair, or two, which is angle B, is congruent to angle D. So I have two pairs of congruent angles. When that's the case on any type of quadrilateral, then it's going to be called a parallelogram. So then that automatically tells me, because this first pair of angles is congruent and the second pair of angles are congruent, that automatically tells me that these two sides will be parallel, opposite sides will be parallel to one another, and thus this will be a parallelogram. Okay? That's just like this first one, which I didn't say. When I have opposite, this one says when opposite side pairs are congruent, then there will be a parallelogram. So although I didn't mark that these two sides are parallel, opposite sides are parallel to one another, the minute I know that AB is congruent to CD and AD is congruent to CB, I automatically know that the two opposite sides have to be parallel, because that's the definition of a parallelogram. Okay? Moving forward. Next theorem is 6.8. If the angles of a quadrilateral are supplementary to both of the consecutive angles, then the quadrilateral is a parallelogram. So here's what I have. If I know that angle A plus the angle of D is going to equal angle A plus the angle of D, and I'll put the measure of angle A plus the measure of angle D. Let me rewrite that for you. The the measure of angle A plus the measure of angle D is equal to 180 degrees or supplementary. And I also know that the measure of angle A plus the measure of angle B, if I call this one consistent, is still equal to 180 degrees. Because these are both true, I did D, and this should be the measure of angle B. Come out of here. Okay, so if the measure, if I hold angle A is my consistent angle, if the measure of angle A plus the measure of angle D is equal to 180 degrees, and at the same time, again, measure of angle A is plus the measure of angle B is equal to 180 degrees, then the quadrilateral ABCD is a parallelogram, and I know that the AB is parallel to CD and AD is parallel to CB. Okay? Moving further. Theorem 6.9, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here are the diagonals. AC and BD are the diagonals. My midpoint right here, M, is there. But this is the key thing. I see that AM is congruent to CM, and at the same time, I see that DM is congruent to BM. We talked about diagonals before. This does not mean that AM is going to be congruent to DM. They're on different diagonals. But if I extended the diagonal AC all the way down, here's the midpoint at M. AM is the same length as CM. I see that because of the congruent markers. And at the same time, I got another pair of congruent segments. I see DM is congruent to BM. Then that means that this is going to be a parallelogram. Okay? Theorem 6.10. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So here's the next thing. On this particular quadrilateral, BCDA, they tell me that BC is parallel to DA. I see they're parallel by the blue marker, and I also see that BC is congruent to DA. So two things happen. BC is parallel to DA with the blue marker, arrowhead. And then BC is also congruent to DA with the red line marker. Now watch, you cannot say that same thing necessarily if I go back and say that AB is parallel to CD, and then I see BC is congruent in length to DA. Again, we don't want to say that if I see that AB is parallel to CD, and then I see BC is congruent to DA, I don't call that a parallelogram. What must be true is the segment length that's congruent and the parallel symbol have to be on the same opposite segments. So here it is here. I can do that here because I'm saying that both this segment BC and DA, or AD, I'll say that again, segment BC and AD, two things happen on those two segments. First of all, they're parallel, and at the same time, they are congruent to one another. So two things on the same segment, okay? So again, I don't want to say that if I see the marker like that. These parallel symbols have to be on the same segment with the congruent sign as well, okay? And there it is. Now we're going to get into some proofs. Let's recall some information about writing proofs. Number one, you always look for given information. Look at the diagram and such, because 6.3 is about writing proofs. Here we go. Sometimes what is given is written in the direction, or in other words, they are written in word form. So sometimes it's given as a picture, or it's written in the directions in word form. If the given is written in word form, then we need to mark up the diagram. Remember, sometimes they may draw a diagram, and they may say on this particular MBCA, they may say that MBCA is a parallelogram. Well, obviously it's not marked, and they may say that the opposite angles are congruent. Well, it's not marked. Well, if it's drawn like this, we need to take upon ourselves and mark it so that we can indicate how we know that this is a parallelogram. So I pick up my green pen and mark up the diagram if the directions didn't do it already for me. Okay? So this is just recall, this is back from chapter 2, notes on how we write a proof. Okay, so first of all, we always look for what's given. If it's not already marked on the diagram, mark it on the diagram. If they don't give me a diagram, I should draw a pictorial diagram and mark it up. Okay, sometimes the given is only a diagram or a drawing. If that's the case, you must write what's being said in word form. So sometimes we have to write things out or draw the picture, as I stated. Next, ask yourself, you always ask yourself, what must I prove? What do I need to prove? What are they asking me to prove to them? Finally, and this is very, very important, you need to remember, you must ask yourself, what information do you need to know in order to write my proof? Now write down everything that you remember, that you know that must be true in order for your proof to be proven. Okay, remember in a proof, you use definitions, postulates, and theorems. So back to that example where I just drew a parallelogram of M, B, C, A, and if they told me that the opposite angles are congruent, I start immediately thinking about what theorems and definitions, 6, 7, 6, 8, 6, 10, what works in here for this particular proof to be true. And I know that opposite angles are congruent on a parallelogram. Therefore, what a parallelogram means is that these two sides are parallel, these two sides are parallel to one another. So BC is parallel to AM, and BM is parallel to AC. Okay? So remember, you need to write down everything. Oh, but I see the two opposite angles, so I'm going to go back to the opposite angles. This is what was given to me. I start thinking to myself, like, okay, what theorem is that? 6 what is opposite angles? And I write down everything. Opposite angles are congruent. What theorem is that? I write down everything I remember about that so I can get ready to line up and see what I can prove in my proof. So let's try a proof. And I'm giving out the answer too soon. Okay? So here we have this parallelogram. We're given that segment AB is congruent to CD and AD is congruent to CB. So here it is. I have if this particular one example is in your book and it's marked, it says that AB is going to be congruent to CD, and I see that AD is congruent to CB. I need to prove that ABCD is a parallelogram. Well, immediately when I see this here, I'm thinking to myself, oh, what theorem was that where they said the two opposite pairs have to be congruent to one another? What theorem was that? So in my mind, you shouldn't need to come back, but if you do come back, when I have the two opposite sides, that's theorem 6, when it says two pairs of opposite segments are congruent on a parallelogram. So I start off with the statements. AB is congruent to CD and AD is congruent to CN. AD is congruent also to CB. That was given. How do I know that AC is congruent to AC? What property is that? That's the reflexive property. Okay? They also have the diagonals drawn in there as well. I have triangle ABC, and I mark it up. Triangle ABC is congruent to triangle CDA. Okay? How is that going to be? By side, side, side. How do I know that? They share this side here. Well, I knew that these two are congruent, BC and AD, and I see AB is congruent to CD. So this is going to be congruent by side, side, side. Right? And then I have, what do I have? I got a lot of jumbled things in here. Hold on, let me fix this up for you. Sorry about that, you guys. Okay. Oh no, come on, stick. I'm gonna put this on part 2 video so I don't hold you. I'm gonna clean this up.